A head-on collision is a traffic collision where the front ends of two vehicles such as cars, trains, ships or planes hit each other when traveling in opposite directions, as opposed to a side collision or rear-end collision. With railways, a head-on collision occurs most often on a single-line railway. This usually means that at least one of the trains has passed a signal at danger, or that a signalman has made a major error. Head-on collisions may also occur at junctions, for similar reasons. In the early days of railroading in the United States, such collisions were quite common and gave to the rise of the term, cornfield meet. As time progressed and signaling became more standardized, such accidents became less frequent. Even so, the term still sees some usage in the industry. The origins of the term are not well known, but it is attributed to accidents happening in rural America where farming and cornfields were common. The first known usage of the term was in the mid-19th century. The distance required for a train to stop is usually greater than the distance that can be seen before the next blind curve, which is why signals and safe working systems are so important. Note: if the collision occurs at a station or junction, or trains are traveling in the same direction, then the collision is not a pure head-on collision and the driver of stop train 4116. Lack of ATB conductor error with shipping. There are two main factors influencing the chance of a head-on collision. Firstly, even with radar and radio, it is difficult to tell what course the opposing ships are following. Secondly, big ships have so much momentum that it is very hard to change course at the last moment. Head-on collisions are an often fatal type of road traffic collision. The NHTSA defines a head-on collision thusly: refers to a collision where the front end of one vehicle collides with the front end of another vehicle while the two vehicles are traveling in opposite directions. In Canada, in 2017, 6,293 vehicles and 8,891 persons were involved in head-on collision, injuring 5,222 persons and killing 377 other. U.S. statistics show that in 2005, head-on crashes were only 2.0% of all crashes, yet accounted for 10.1% of U.S. fatal crashes. A common misconception is that this overrepresentation is because the relative velocity of vehicles traveling in opposite directions is high. While it is true that a head-on crash between two vehicles traveling at 50 miles per hour is equivalent to a moving vehicle running into a stationary one at 100 miles per hour, it is clear from basic Newtonian physics that if the stationary vehicle is replaced with a solid wall or other stationary near a movable object such as a bridge abutment, then the equivalent collision is one in which the moving vehicle is only traveling at 50 miles per hour. Except for the case of a lighter car colliding with a heavier one. The television show Mythbusters performed a demonstration of this effect in a 2010 show. In France, in the years 2017 and 2018, 2,563 and 2,556 head-on collisions outside built-up area outside motorways killed 536 and 545 people, respectively. They represent about 16% of all the fatalities, including the ones on motorways and within built-up area. In Quebec, head-on collisions are involved in 8% of work-related issues, but 23% when two vehicles are involved in rural high-speed zone where the maximum speed is greater than 70 km per hour. Head-on collisions, side swipes, and run-off road crashes all belong to a category of crashes called lane departure or road departure crashes. This is because they have similar causes, if different consequences. The driver of a vehicle fails to stay centered in their lane and either leaves the roadway or crosses the center line, possibly resulting in a head-on or side-swipe collision. Or, if the vehicle avoids oncoming traffic, a run-off road crash on the far side of the road. Preventive measures include traffic signs and road surface markings to help guide drivers through curves, as well as separating opposing lanes of traffic with wide central reservation and median barriers. To prevent crossover incidents, median barriers are physical barriers between the lanes of traffic, such as concrete barriers or cable barriers. These are actually roadside hazards in their own right. But on high-speed roads, the severity of a collision with a median barrier is usually lower than the severity of a head-on crash. The European Road Assessment Programme's road protection score is based on a schedule of detailed road design elements that correspond to each of the 4 main crash types, including head-on collisions. The head-on crash element of the RPS measures how well traffic lanes are separated. Motorways generally have crash protection features in harmony with the high speeds allowed. The star rating results show that motorways generally score well with a typical 4-star rating even though their permitted speeds are the highest on the network. But results from star rating are